Hey guys, it's Miss Marnon. So yesterday we worked with the associative and commutative properties to generate equivalent expressions. Today we're going to use the distributive property. This is one that I think we need a lot of practice with, but it's the one that I always say everybody gets cake, and we'll see what that means in a minute. So our objective today is I can use the distributive property to write equivalent expressions in simplest form. So our review question for our DIN, write an equivalent expression in simplest form for the expression 3 times 7x plus 3 times negative 5. So pause the video and see if you can write an equivalent expression for this. Okay, so something you might have done was you might have used the associative property here. So instead of doing that 7 times x first, you could have said I want to do 3 times 7 first. And now all we have left is doing these multiplications. Because they're separated by addition, they're two separate terms, we can actually multiply in the same step. So 3 times 7, this will leave us with 21x, plus 3 times negative 5 is negative 15. So our simplest form is 21x plus negative 15. You could have also written 21x minus 15. We know that adding a negative is the same as subtracting the positive, so both of these answers would be correct. For our preview question, use the distributive property to evaluate 4 times the quantity 10 plus 7. Show your work with both an area model and algebra. So see if you can figure this out. You've done distributive property before. If you need help, I'll help you in just a moment, but try to see if you can do this on your own. Okay, the first thing I'm going to do is I'm actually going to do my area model first. I'm going to give myself a little more space. So an area model is exactly what it sounds like. You guys have been using them for a very long time. We want to find the area of this rectangle. We know area is length times width, so it's like we want to do it. This is 4 times the length here is going to be our 10 plus 7. And what we're going to do is we're going to split our rectangle up. Now we have two rectangles. So if I can find the area of this rectangle and this rectangle, I can add them together and get the area of the whole rectangle. So what we're going to do is we're going to do 4 times 10. We'll go in this box. That is 40. And 4, right, because that's the same width right here, times 7 will give us the area of this box. So that is 28. So now the area of the first box is 40. Area of the second box is 28. We can add them together. And we get that it is 68. So this is my everybody gets cake, right? So the 10 got multiplied by 4, the 7 gets multiplied by 4. If we wanted to show this without a picture, it's just everybody gets the 4. So the 10 gets some 4 and the 7 gets some 4. So we would write this as 4 times 10 plus 4 times 7. Now it's just going to be the same thing. 4 times 10 is 40, plus 4 times 7 is 28, and 40 plus 28 is 68. So both ways work. We're going to use both ways today in our lesson. We're going to use area models. We're going to use some algebra. Whatever way ends up working best for you, use that way. So let's look at some of our notes here. Consider the expression 2 times the quantity x plus 7. Evaluate the expression for x equals 3. So pause the video, substitute 3 in for x, and figure out what value it is. Okay, so you could have done this out by hand, or you could have done it on the calculator. So if I just put a 3 everywhere I see an x, I can do this by hand. I would start in the parentheses. 3 plus 7 is 10. I have 2 times 10, which is 20. If I wanted to use this on the Desmos calculator, I would first need to tell my calculator x equals 3 and then hit enter. Now we can type in this original expression, 2 times the quantity x plus 7. Either use the buttons on Desmos, you can get the letters by going to ABC and the equal sign, or you can just type it right on your keyboard as I did. And we can see on the calculator, we also got the expression is equal to 20. So part B, what expression do you think would be equivalent to 2 times the quantity x plus 7? So you can pause the video and play around with this and see what you get. I think we're going to have to do something with distributive property. So pause the video, see what you get. Okay, so hopefully you tested this out a little bit. Let's try to do it with an area model, just like we did with our preview question in our DIN. So I'm going to draw my rectangle. We want 2 times x plus 7. So we're going to have 2 on the side and x plus 7. If I was going to get the area of this rectangle, I'd have to multiply these two things together. But we're going to split it in half. So we have 2 times x and 2 times 7. Well, 2 times x, I can't really do anything with it. That just says 2x. And 2 times 7 for this box is 14. If you wanted to just do it algebraically and everybody gets cake, you can see that we would do 2 times x plus 2 times 7. And we get the same thing, 2x plus 14, because this is also, we would add these together to get 2x plus 14. It now wants us to test our expression from part B using x equals 3. So did this really make an equivalent expression? So let's try it. Let's put 3 where we see an x. So instead of 2x plus 14, we're going to try 2 times 3 plus 14. So we have 2 times 3 plus 14. 2 times 3 is 6. Plus 14 is 20. That's what we got up here, so that checks out. If we wanted to use it on our Desmos calculator, we already told it that x is 3. So we can just type in 2x plus 14, and it will say 20. Now, the cool thing about this on Desmos is if we wanted to see, well, are these really equal? Are they really equivalent expressions for every value of x? We can actually click up here and try all different values of x and see that both expressions will get the same answer. So when we're checking these things on Desmos, you could really type them in, check a bunch of different values, and see that they really are the same for every value of x. When I put in x is 54, this is 122, this is 122. They are equivalent expressions. Exercise 2. Consider the expression 5 times the quantity, 3x plus 4. Justify each of the steps for simplifying the expression using a property or operation. So this is like what we did yesterday. So if we look here, here's the work, here's the explanations. So this is just the original expression. Then it looks like they took the 5 and they multiplied it by the 3x and they multiplied it by the 4. What property is that? Pause the video and fill out this box with the property. Okay, so hopefully you saw that when everybody gets the 5, everybody gets cake. That's our distributive property. Now what they did is they took this 5 times 3 and they wanted to multiply that first. What property is that? Pause the video and put that property there. So hopefully you saw that they reassociated it. So that's our associative property. And lastly, they just did the 5 times 3 is 15 and 5 times 4 is 20. That's just multiplication. Exercise 3, rewrite each expression using the distributive property. So why don't you pause the video and try part A on your own. Okay, so hopefully you tried part A on your own. I'm going to do it first with an area model and then I'll do it just algebraically. So I'm going to draw my box for my area model. I'm going to have 3 times 4x plus 7. I'm going to split this in half. So this is the 4x, this is the 7. In the first box, I have 3 times 4x. Well, 3 times 4 is going to be 12. And the x just kind of comes along for the ride. We can't do anything with it because we don't know what number it is. 3 times 7 for this box, we get 21. So we got 12x plus 21. If you just wanted to do this quickly and algebraically, you could have done everybody gets cake, everybody gets 3. So 4x gets 3 and 7 gets 3. So that would look like 3 times 4x plus 3 times 7. 3 times 4x, you could just use associative property. 12x plus 3 times 7 is 21. Both ways, same answer. Part B, we have 8 times 3x minus 2. I think yesterday I told you guys that whenever you can, change minus to adding a negative. So let's actually go in and change this right here on our own. So just change it to adding a negative 2. And that's going to make it easier for us. So, and let's make that purple so we can see that I changed that. Pause the video and see if you can do this distributive property on your own. Okay, so I'm going to help you now. So we're going to do an area model first, and then we'll do it just algebraically. So let's draw out my rectangle. We have 8 times 3x plus negative 2. So this is my 8. This is my 3x plus negative 2. Split it right at the plus. 8 times 3x and 8 times negative 2. Well, 8 times 3 is 24, and the x just kind of comes along for the ride. 8 times negative 2 is negative 16. So you could write this as 24x plus negative 16, or you could even just say 24x minus 16. They're exactly the same. You can have it 24x plus negative 16 if you like that way better. Algebraically, this would be everybody gets cake, which would be 8 in this instance. So everybody's going to get 8. 3x gets 8. Negative 2 gets 8. So that's 8 times 3x plus 8 times negative 2. We can associate this 8 times the 3. This is 24x plus 8 times negative 2, negative 16. And we all know I like to put parentheses around when I'm adding negatives. So challenge question. How do you know your simplified expressions are equivalent to the original expressions? So what could you do with this original one, this 8 times 3x plus negative 2 or minus 2? And how do I know that's the same as 24x minus 16? Well, what did we do here to check? So what we could do is we could test different values of x. In the original and the simplified expressions. And that would be easy on our Desmos calculator, right? So I could clear this all out and I could say, okay, I want x equals 5 to start. Something, you could pick any number. And then let's just do this first one. 3 times the quantity 4x plus 7. And then our other expression, we said 12x plus 21. We can see when x is 5, they're both 81. So you can actually go through and check a bunch of different numbers. You can do negative 10,000 even, and see that they're going to be the same value for every x. So that's just a quick way we can check that. So now we have our practice. So you have 3 practice expressions. Simplify each expression using the distributive property. You don't have to do both ways. If you like the area model, just do the area model. If you like doing it algebraically, just do it algebraically. You only have to pick one way and go with it. And maybe it switches for each one, but don't do it twice. You only have to do it once. On our exit ticket, you have another one, this expression. It wants you to rewrite it. So this is a sum, right? Right now we have a difference. So how can I change it to adding? And then use the distributive property to write an equivalent expression. When you're done with your practice and your exit ticket, you can go onto Canvas and complete independent practice 26.